January 1941, Ford production chief Charles Sorensen sat in a San Diego hotel room, sketched a massive factory layout, and made an impossible promise. One B-24 Liberator bomber every single hour. Aviation experts scoffed. Combat aircraft were highly complex, handcrafted machines, not Model T cars. And for the first 2 years, those experts were right. Ford's billion-dollar Willow Run plant descended into absolute chaos, churning out disastrous headlines instead of heavy bombers. The national press mercilessly dubbed the failing facility Willow Run. This isn't the sanitized myth of an overnight industrial miracle. It is the story of an arrogant logistical nightmare that nearly broke the Allied war effort. Behind the pristine wartime propaganda, the patriotic posters, and the upbeat radio broadcasts lay a brutal, unforgiving clash of industrial cultures. We are going to examine how Detroit's rigid, deeply entrenched assembly line logic violently collided with the fluid, constantly evolving demands of military aviation. In 1941, the United States didn't just need airplanes. It needed an overwhelming mechanical advantage to fight a rapidly expanding war on 2 separate fronts. But translating automotive manufacturing principles into the production of heavy bombers was not a matter of simply flipping a switch or hiring more hands. This is a story about the raw mechanics of industrial warfare, entirely stripped of its heroic mythology. How exactly did a chaotic, hastily assembled workforce, composed largely of people who had never set foot on a factory floor, manage to overcome deeply flawed initial strategies and monumental engineering miscalculations? How did they push past the humiliating national headlines to eventually refine a system capable of crushing the Axis powers under a relentless, staggering avalanche of heavy aluminum? The path to that legendary output was paved with systemic breakdowns, intense bureaucratic friction, and the painful realization that building a 30-ton combat aircraft is nothing like rolling a commercial sedan off an assembly line. To understand why this colossal factory nearly collapsed under its own weight before it ever succeeded, we first have to look at a fundamental mismatch in how these machines were actually built. The fundamental mismatch began at the drafting table. In the late 1930s, the American aviation industry was effectively a boutique enterprise. Aircraft companies like Consolidated, the original designer of the B-24 Liberator, built their machines in small, specialized batches. Their assembly floors looked more like massive artisan workshops than modern industrial conveyor belts. This was not a flaw. It was a strict military necessity. A combat aircraft in the middle of a global war is not a static product. It is a living, breathing document, constantly subject to the brutal, unforgiving feedback of the front lines. When British pilots flying early models of American bombers over Europe discovered that German Messerschmitts could easily exploit a blind spot in the tail, the design had to change immediately. Aircraft manufacturers relied on fluid blueprints and flexible temporary tooling, often using wood, sand molds, or soft zinc alloys. If the War Department demanded heavier armor plating, a new top turret, or self-sealing fuel tanks, the aviation engineers could alter their production methods overnight. The priority was technological survival, not volume. Detroit operated in a completely different universe. The American automotive industry was built on the unyielding religion of mass production and absolute standardization. To build automobiles at scale, companies like Ford relied on massive, rigid, hardened steel dies. These monolithic tools cost fortunes to create and took months to precisely calibrate. But once installed, they could stamp out hundreds of thousands of identical steel fenders, doors, and chassis without a single deviation. The entire financial and operational logic of an automotive plant depended on freezing a design for an entire model year. You did not stop a Ford assembly line to change the shape of a steering wheel midway through a shift. Now, the War Department was asking Detroit to apply its rigid steel tooling to a machine that fundamentally defied standardization. The B-24 Liberator was a deeply complex, 30-ton weapon of war. It consisted of more than 30,000 unique parts, held together by roughly 300,000 individual rivets. And, unlike a commercial sedan, which utilized heavy, forgiving steel. The B-24 was constructed from duralumin, a lightweight, fragile aluminum alloy that required completely different handling. It was prone to cracking if stamped with too much force or bent at the wrong temperature. The aerodynamic tolerances were microscopic. An automotive worker was trained to forcefully hammer a misaligned car door into place on the line. If a worker applied that same blunt force to the stressed metal skin of a bomber wing, the structural integrity of the aircraft was compromised. At 20,000 feet over Germany, under intense atmospheric pressure, that compromised wing would violently tear itself apart. To force these two incompatible cultures together, Ford required a facility of unprecedented scale. They could not retrofit existing automobile plants. They needed a completely new industrial footprint. They chose a tract of farmland near Willow Run Creek in rural Ypsilanti, Michigan, nearly 30 miles outside of Detroit. It was a massive geographical expanse, perfect for a mile-long assembly building and an adjoining airfield. But it possessed absolutely zero civic infrastructure. There were no paved roads capable of handling heavy commuter traffic, no power grids scaled for mass industry, no water treatment facilities, and critically, nowhere for an industrial army to live. As the massive steel skeleton of the Willow Run plant rose from the freezing Michigan mud, a desperate, nationwide call for labor went out. The traditional Detroit workforce had already been heavily depleted by the military draft. To fill the looming vacuum, a massive influx of entirely new demographics began migrating to rural Michigan. Tens of thousands of displaced southern agricultural workers, Appalachian miners, and women who had never previously set foot inside a heavy manufacturing facility answered the call. They traveled by train, by bus, and in dilapidated cars, expecting the high wages promised by wartime industry. What they found upon arrival was a brutal, completely unprepared environment. Because there was no housing infrastructure within miles of the plant, workers and their families were forced into makeshift, desperate living conditions. As the harsh, freezing Michigan winter set in, thousands of workers found themselves living in cramped, uninsulated trailers. Others were forced to live in tents pitched directly in the snow, in abandoned chicken coops, or sleeping in the back seats of their cars. There was a severe lack of basic sanitation, clean drinking water, and medical care. Epidemics of respiratory illnesses swept through the makeshift camps. The grueling, hours-long commute from Detroit on unfinished, heavily congested two-lane roads left workers exhausted before their shifts even began. A massive humanitarian and logistical crisis was brewing right outside the factory doors. Within the cavernous walls of the unfinished plant, a highly volatile mixture had been created. You had a workforce completely untrained in the delicate art of aircraft manufacturing, enduring miserable living conditions, attempting to execute the vision of automotive executives who fundamentally misunderstood the machine they were building. Ford's veteran engineers, steeped in decades of automotive supremacy, dismissed the warnings of the aviation experts. They firmly believed they could stamp out heavy bombers just like car fenders, completely ignoring the fluid, demanding reality of aerial warfare. And they held tightly to this arrogant conviction, right up until the moment the first metal parts actually started coming off the line. The collision between Detroit's rigid tooling and the fluid nature of aerial warfare was instantaneous and catastrophic. As the first massive steel dies hammered down onto sheets of raw duralumin, Ford engineers realized they were trapped in an engineering nightmare. The Army Air Forces were receiving daily combat reports from the skies over Europe. A new defensive tactic meant a sudden demand for thicker armor plating. A different bombing formation required a completely redesigned tail turret. By the time Ford spent months casting, cooling, and carefully calibrating a massive steel mold to stamp out a specific fuselage panel, the military had already altered the blueprint. Dozens of these incredibly expensive, monolithic tools were rendered completely obsolete before they ever contributed to a single combat-ready aircraft. They were quietly hauled off the factory floor and sold for scrap. But the true breaking point arrived when the factory attempted to actually assemble the machine. In the automotive world, a stubborn steel car door could be shoved or bent into place. A heavy bomber, however, is an unforgiving mathematical equation with aerodynamic tolerances measured in microscopic fractions of an inch. When the early subassemblies of the B-24 rolled down the unfinished conveyors to be joined together, The major components simply did not fit. Massive wing sections would not properly mate with the central fuselage. Internal bulkheads were severely misaligned. Thousands of pre-drilled rivet holes completely failed to match up. Facing impossible production quotas and screaming floor managers, the hastily trained workforce panicked. The migrant farmers, former miners, and displaced shop clerks grabbed rubber mallets, pry bars, and heavy tools. They frantically began hammering, stretching, and physically bending the delicate aluminum components directly on the assembly line, desperately trying to force the mismatched pieces to connect. This was not precision aviation manufacturing. It was industrial butchery. The brutalized duralumin warped under the extreme physical stress. The untrained workers were fatally compromising the structural integrity of the aircraft before it ever left the ground. The factory was not building an armada. It was churning out incredibly expensive, highly dangerous junk. The military command was furious. By the late summer of 1942, the plant was hemorrhaging money while producing only a tiny fraction of the promised bombers. The few aircraft that did manage to limp out the factory doors were immediately rejected by military inspectors, riddled with severe mechanical and structural defects. The United States government realized that standard automotive mass production was fundamentally failing to meet the reality of wartime aviation. The Truman Committee, a senatorial body tasked with investigating wartime waste, descended on the struggling facility. High-ranking military officials drafted aggressive contingency plans to pull the plug on the entire billion-dollar project. The threat was explicit. If the chaotic production lines were not immediately fixed, the War Department would forcefully seize the plant and strip the Ford Motor Company of its control. Facing total, humiliating failure and an imminent federal takeover, the veteran automotive engineers had to abandon their stubborn pride. To save the project, they had to do something no aviation company and no automaker had ever attempted. They had to take the 30-ton heavy bomber and break it down to its absolute molecular level. The solution was an act of aggressive, unprecedented industrial deconstruction. Ford's executives, realizing that their initial attempt to forcefully stamp out airplanes like commercial sedans was leading to catastrophic failure, ordered a complete and total overhaul of the manufacturing process. They abandoned the idea of building a massive aircraft from the ground up in a single, static location. Instead, they took the highly complex aeronautical blueprints of the consolidated B-24 Liberator and sliced the 30-ton machine into major modular components. The bomber was conceptually shattered into discrete, manageable pieces: the forward fuselage, the aft fuselage, the center wing section, the outer wing panels, and the tail empennage. But dividing the aircraft into sub-assemblies was only the first step. To completely eliminate the need for skilled aviation mechanics, Ford's engineering team broke those massive sub-assemblies down even further, separating them into individual aluminum panels, and then breaking those panels down into hundreds of hyper-specific, microscopic tasks. The overarching philosophy was to entirely remove human judgment from the factory floor. In a traditional aviation plant, a mechanic needed years of specialized apprenticeship to intuitively understand how a stressed metal wing was supposed to fit together, manually adjusting and filing pieces until they formed a perfect aerodynamic curve. At Willow Run, engineers designed and poured massive, rigid steel jigs, heavy, immovable metal frameworks that held the fragile aluminum components in such a precise, uncompromising grip that the worker did not need to think about aerodynamics at all. They engineered a system of foolproof tooling. Holes were pre-drilled into the metal with mathematical precision. If a worker picked up a piece of duralumin skin and the holes did not perfectly align with the underlying skeletal frame, it simply meant they were holding the wrong piece, or holding it upside down. Electrical wiring was color-coded and cut to exact lengths before it ever reached the aircraft. They transformed the highly sophisticated, elite art of aeronautical engineering into a relentless series of incredibly mundane, repetitive motions. You did not need to know how to build a strategic heavy bomber to work at Willow Run. You only needed to know how to insert a specific rivet into a specific slot exactly the same way, thousands of times a day. With the engineering fundamentally simplified, management faced its next monumental hurdle: training a desperate, entirely unskilled civilian workforce to execute these tasks at a grueling wartime pace. The tens of thousands of displaced agricultural workers, former coal miners, and housewives who had flooded into the freezing, muddy trailer parks surrounding the plant, were marched into massive, hastily constructed vocational schools. The primary skill they had to master was riveting, because the structural integrity of the B-24 relied entirely on the more than 300,000 aluminum rivets that held its skin together. Driving a rivet was not a simple mechanical action. It was a brutal, physically exhausting two-person ballet of synchronized force. It required one worker, usually standing on the outside of the aircraft panel, to operate a heavy, vibrating pneumatic rivet gun. A second worker, known as the bucker, had to crawl inside the cramped, suffocatingly tight spaces of the aluminum wing or fuselage. The bucker held a solid block of steel, the bucking bar, firmly against the tail of the rivet. When the trigger was pulled, the pneumatic gun delivered a deafening, rapid-fire series of blows that hammered the rivet head flat, while the bucking bar on the other side mushroomed the tail, locking the metal sheets permanently together. The physical toll of this training was immediate and severe. The pneumatic guns violently rattled the bones of the arms and shoulders, leaving workers with numb hands and aching joints. The noise inside the training hangars was indescribable, a continuous, deafening metallic chatter that made spoken communication physically impossible, forcing teams to rely entirely on taps and hand signals. Into this punishing environment stepped demographics that the American heavy manufacturing industry had historically ignored or marginalized. Because the military draft had siphoned off the vast majority of able-bodied white men, Ford was forced to aggressively hire women. These were not the pristine, smiling, glamorous figures depicted on patriotic government propaganda posters. They were former waitresses, school teachers, and domestic workers who stepped onto the floor wearing heavy denim coveralls, their hair tied back tightly in bandanas to prevent being caught and scalped by high-speed drill presses. They emerged from their 9-hour shifts covered in aluminum dust, their hands bruised and calloused, their hearing temporarily diminished by the relentless roar of the pneumatic guns. Simultaneously, thousands of African Americans who had migrated from the Jim Crow South in search of wartime wages were integrated into the plant. Initially relegated exclusively to janitorial and menial labor by deeply entrenched corporate racism, the sheer, undeniable desperation for manpower forced factory floor managers to put them on the assembly line. They worked side by side with white laborers from the rural Appalachian Mountains, creating intense racial friction and cultural clashes that management had to constantly and sometimes ruthlessly suppress in order to keep the machinery moving. The workers would finish their grueling, physically destructive shifts, walk out of the cavernous, chemical-smelling plant, and return to the freezing, unsanitary tent cities and trailer parks that still lacked adequate heating and clean water. It was a pressure cooker of exhaust, noise, and raw human endurance. Half a world away, across the Atlantic and the Pacific, Axis intelligence agencies were meticulously analyzing the reports coming out of Michigan. German and Japanese high commands read the translated American newspaper articles detailing Ford's massive billion-dollar investment and the arrogant promise of producing one heavy bomber every hour. Their reaction was not fear, it was absolute, dismissive mockery. To understand the enemy's perspective, one must understand the deeply ingrained philosophy of European and Japanese aviation manufacturing. In the factories producing the Luftwaffe's Messerschmitt fighters or the Imperial Japanese Navy's Mitsubishi Zeros, aircraft construction was treated as a guild-like profession. Axis warplanes were assembled by master craftsmen, men who possessed decades of highly specialized, intuitive experience. These craftsmen hand-filed metal edges to ensure a perfect fit, custom-molded glass canopies, and understood the holistic nature of the machine they were building. They viewed American industrial claims through a lens of profound cultural superiority. Hermann Göring and the Luftwaffe's top engineering minds concluded that the American promise was a mathematical and physical impossibility. You cannot, they argued, take a semi-literate farmer or a housewife, place a pneumatic drill in their hands, and expect them to construct a high-altitude, long-range, strategic bomber capable of surviving heavy flak, extreme atmospheric pressure, and sub-zero temperatures. The Axis leadership fundamentally believed that standardizing a combat aircraft to such a microscopic, mass-produced level would result in a brittle, defective machine that would simply tear itself apart in the sky. To the German and Japanese high commands, the American reliance on mass production over master craftsmanship was evidence of spiritual weakness and industrial hubris. They viewed the highly publicized Willow Run project as nothing more than a colossal, desperate propaganda stunt, an American fantasy that was already actively collapsing under the weight of its own incompetence. While the enemy laughed, Ford executives were actively ignoring the international mockery to focus on a terrifying, unforgiving mathematical reality back in Michigan. A moving assembly line is a ruthless master. If a worker at Station 42 is missing a specific aluminum bracket or a handful of specialized screws, Station 43 cannot do its job. Within minutes, the delay cascades, and the entire mile-long factory grinds to a catastrophic halt. To prevent this, Ford had to orchestrate a logistical nervous system that was entirely unprecedented in the history of human industry. The 30,000 unique parts required to build a single B-24 Liberator were not all manufactured on site. Willow Run was the final destination for a massive, sprawling national supply chain. Massive Pratt & Whitney radial engines were built in Connecticut. Specialized rubber tires were vulcanized in Akron, Ohio. Plexiglass noses and turrets were formed in Toledo. Gyroscopes, advanced radio arrays, highly classified Norden bomb sights, hydraulic fluids, and miles of copper wiring were produced by hundreds of separate subcontractors spread across the entire North American continent. To feed the beast of Willow Run, Ford essentially birthed the modern concept of just-in-time manufacturing out of sheer wartime desperation. They constructed massive railway spurs that did not just lead to the edge of the factory property. The tracks went directly inside the cavernous building. Boxcars, loaded with engines and aluminum sheets, rolled directly up to the assembly bays. Fleets of heavy transport trucks operated on synchronized, down-to-the-minute schedules to deliver components precisely when the workers needed them. The physical layout of the assembly floor was a marvel of spatial engineering. The plant was so unimaginably massive, stretching over a mile in length and a quarter-mile in width, that the primary assembly line had to make a sharp 90-degree turn just to avoid crossing the property line into the neighboring county, giving the floor its famous L shape. Raw materials and subassemblies entered one end of the L, moving through a complex matrix of stamping presses, chemical treatment baths, and riveting stations. The major modules, the forward and aft fuselages, gradually moved toward the center of the line. There, they met a mechanical ballet, coordinated by aggressive foremen with stopwatches, teletype machines, and an army of logistics clerks. Massive, mechanized overhead cranes would slowly glide across the ceiling, carrying a 70-foot, fully assembled center wing section. With microscopic precision, the crane operators would lower the massive wing down onto the awaiting fuselage. Because of the ruthless standardization of the steel jigs, the mating points aligned perfectly. Workers rushed in, driving the massive steel bolts home, and suddenly, a chaotic pile of aluminum parts looked like an airplane. By the late spring and summer of 1943, the chaotic, violent noise of Willow Run began to synchronize into a steady, rhythmic heartbeat. The embarrassing mountains of scrapped, warped aluminum outside the factory doors began to shrink. The workers' blistered hands developed hard calluses and automatic muscle memory. The punishing training was finally taking hold. The production numbers, which had initially been an embarrassing, highly publicized trickle, slowly began to climb. One completed bomber rolled out the massive hangar doors in a week, then one a day, then 3 a day. Across the Atlantic, as these massive 4-engine olive-drab machines began darkening the skies over occupied Europe, the tone of Axis intelligence intercepts began to shift dramatically. The mocking dismissal evaporated. Luftwaffe reconnaissance pilots and frontline interceptor squadrons were suddenly encountering overwhelming, tightly packed combat box formations of B-24 Liberators. But the true realization of what the Americans had achieved did not happen in the sky. It happened on the ground. When Axis aeronautical engineers thoroughly examined the wreckage of downed Liberators scattered across the German countryside, they made a chilling discovery. The intricate components on these massive bombers were perfectly, flawlessly interchangeable. An outer wing panel from a B-24 shot down on a Tuesday was identical, down to the exact millimeter, to a panel on a completely different B-24 shot down on a Friday. There were no tool marks left by master craftsmen. There was no evidence of manual filing or bespoke fitting. There was only the cold, terrifyingly precise uniformity of machines building machines. A quiet, creeping alarm set in among the German and Japanese high commands. The realization finally hit them, completely shattering their belief in artisan superiority. The Americans were not just building airplanes. They had successfully manufactured a weaponized industrial conveyor belt, and they were pointing it directly at the heart of the Axis empire. On paper, this unprecedented logistical and engineering system was finally working exactly as Charles Sorensen had arrogantly promised on that hotel napkin, transforming a national embarrassment into a roaring triumph of mass production. But behind the closed doors of the factory, those legendary, soaring production numbers were hiding a much darker, fundamentally unsustainable reality on the assembly floor. The staggering statistical victory of 1944, the moment Willow Run actually hit the legendary output of one bomber every 60 minutes, came with a savage human cost. Behind the patriotic facade of industrial might, the factory floor was a brutal environment of physical and psychological attrition. The unceasing, deafening roar of pneumatic rivet guns, combined with the toxic chemical haze of paint fumes and anti-corrosive sprays, created an environment that was fundamentally incompatible with human endurance over a 9-hour shift. The relentless mechanical pace of the conveyor belt demanded a speed that broke bodies and spirits. The result was a catastrophic, largely hidden humanitarian logic. Ford didn't have a static workforce of refined craftsmen. They had a human conveyor belt of their own. Every single month, the Willow Run Employment Office was forced to hire thousands of entirely new workers simply to replace the equal number who had quit in a state of utter exhaustion, medical burnout, or severe psychological distress. They were pouring untrained civilians into the machine to keep the line moving at any cost. Furthermore, maintaining that mythical plane an hour milestone required a terrifying strategic calculation. In a fast-moving air war over Europe, combat requirements changed daily. As German defensive tactics evolved, standard heavy bombers needed updated radar systems, better protective armor for the flight crew, and revised gun turrets. Ford executives in Detroit looked at these critical, life-saving military update orders and aggressively ignored them. They stubbornly refused to stop the moving assembly line to retool for new designs. They knew that halting the massive steel presses and jigs to install current combat upgrades would shatter their production quotas. To meet Charles Sorensen's impossible numerical promise, Willow Run intentionally froze the B-24 design. The result was that Ford was delivering thousands of heavy bombers that were slightly, but significantly, outdated before they ever left the Michigan airfield. American pilots were being forced to fly into hazardous, heavily defended airspace in machines that lacked the most modern survival equipment, simply because the Ford Motor Company could not stop the line. Quantity had become the only priority, and in the spring of 1944, that ruthless pursuit of quantity finally climaxed into a terrifying, synchronized industrial rhythm. Whatever the strategic cost of frozen designs or the daily human toll of physical burnout, the Willow Run machine had achieved its ultimate form. The mile-long assembly line, once a chaotic, humiliating landscape of warped aluminum and panicked laborers, was now roaring at maximum, unrelenting capacity. It was an awe-inspiring but deeply impersonal spectacle that reduced the incredibly complex physics of flight into the mindless, unforgiving ticking of a factory clock. Inside the cavernous L-shaped building, the manufacturing process had become a fluid, continuous river of aluminum. The immense physical scale of the operation was staggering, operating with a momentum that seemed completely detached from human control. Massive, mechanized overhead cranes, gliding smoothly through the chemical haze above the deafening chatter of pneumatic rivet guns, hoisted fully assembled 70-foot center wing sections high into the air. With microscopic precision dictated entirely by the rigid steel jigs, the crane operators seamlessly lowered these massive structures down onto the awaiting fuselages. The colossal components no longer needed to be coerced, bent, or hammered into compliance. They simply locked, perfectly into place, mated by the unyielding logic of the conveyor belt. This mechanical ballet operated 24 hours a day, 7 days a week, completely blind to the outside world. The factory never slept, never paused, and never slowed down. It existed in a state of perpetual motion, under a harsh grid of artificial lights, fueled by a continuous human conveyor belt of exhausted laborers rotating endlessly through their shifts. And at the far end of this grueling, mile-long gauntlet, the impossible statistical promise was finally being fulfilled. Massive, heavy steel hangar doors would slide open, revealing the sprawling Michigan airstrip outside, and every 63 minutes, a fully completed 30-ton heavy bomber rolled out onto the tarmac. Let that terrifying arithmetic sink in. More than 1 million individual parts, 300,000 rivets, miles of specialized copper wiring, and 4 massive Pratt & Whitney engines, all consolidated into a lethal 4-engine strategic weapon of war, completed in barely more than an hour, day and night, week after week. It was an industrial output that dwarfed anything the human race had ever previously witnessed. The United States was no longer just producing aircraft. It was manufacturing a mechanized avalanche. The sheer, incomprehensible scale of this output became a strategic weapon in its own right. The American strategy did not rely on fielding an armada of individually perfect, master-crafted machines like the Axis powers. It relied entirely on overwhelming the enemy with a relentless, crushing volume of heavy machinery that they could not possibly match, intercept, or destroy fast enough. Luftwaffe anti-aircraft batteries and Axis interceptor squadrons could shoot down 10, 20, or 50 Liberators in a single, bloody afternoon over Europe. But the cold mathematical reality was that the Willow Run conveyor belt was already replacing those lost machines faster than the enemy could pull the trigger. Charles Sorensen's arrogant, heavily ridiculed hotel napkin sketch from 1941 had ultimately materialized into a staggering physical reality. The factory had done exactly what it promised, forging an undeniable logistical triumph. But the brutal, uncompromising method by which it achieved that unprecedented success had fundamentally altered the nature of modern warfare forever. The sanitized myth of the arsenal of democracy prefers to remember this achievement as a stroke of flawless, immediate corporate genius. It is far more comfortable to look at the vintage propaganda reels and believe that American industry simply flipped a switch, instantly transforming automotive plants into patriotic bomber factories. But the true legacy of Willow Run is far more complicated and infinitely more grueling. That legendary promise of 1 Liberator every hour was not secured in an executive boardroom. It was paid for through agonizing trial and error, months of humiliating failure, and the brutal, unforgiving standardization of human labor. The real architects of this statistical triumph were the marginalized, overlooked civilians, the former sharecroppers, the Appalachian coal miners, the women, and the displaced minorities. They were the ones who endured the freezing, unsanitary trailer parks of Ypsilanti. They were the ones who absorbed the deafening, bone-rattling shock of the pneumatic guns, shift after shift, turning their own bodies into an expendable component of the assembly line to keep the metal flowing. Willow Run did not just produce a fleet of heavy bombers. It built deeply compromised, frequently outdated aircraft, actively sacrificing technological superiority for sheer, overwhelming volume. But in doing so, it permanently rewrote the rules of global conflict. Before 1941, aerial warfare was still fundamentally viewed through the lens of a boutique, artisanal craft. Willow Run violently stripped away that romantic illusion. It proved, with terrifying mathematical certainty, that in the modern era of total war, victory would no longer be decided solely by the nation with the bravest fighter pilots or the finest master craftsmen. The skies over Europe and the Pacific were ultimately conquered on the ground, in the noisy, chemical-soaked expanses of a Michigan factory floor. The ultimate weapon of the Second World War was not a specific bomb or a single airplane. It was the crushing realization that the future belonged to whichever nation could figure out how to take unimaginable, 30-ton complexity and ruthlessly industrialize it. The Axis powers had spent years meticulously crafting their war machines, relying on an elegant, highly sophisticated philosophy of conflict, where master artisans hand-filed every metal edge to absolute perfection. But elegance could not survive a brutal war of global attrition. In the end, the elite craftsmen of Europe and Japan were not defeated by superior aeronautical engineering or a sudden stroke of tactical genius. They were systematically buried under a relentless, uncompromising avalanche of aluminum, produced by a nation of displaced farmers and housewives who simply figured out how to manufacture heavy bombers exactly like they built cars.